Okay, we're going to talk today about bearing, which it's a navigation term, a surveying term. In navigation and surveying, we use bearing, and we can use our trig functions to help us determine bearing. And a bearing measures the acute angle, or the acute angle from either north or south, and a line of sight. Right. And so here's some examples. Now this is bearing. When we're talking navigation and bearing, usually from the north-south angle, we're talking about ship navigation. But air navigation is always off of north, and it does not have to be an acute angle. So if you're talking airplane navigation, it could, and remind me, and I'll talk about that again in a minute. Let's look at this first. Notice that when we're talking bearing, if it's not air navigation, we're always off of a north-south line. We're looking at the acute angle from north or the acute angle from south. What is an acute angle? Less than 90 degrees. Now here in this first picture, we have a bearing of north 25 degrees east. Notice the 25 degrees is from north, and it's to the east of north. So this bearing is north 25 degrees east. The second picture, we're showing south because we're measuring the acute angle south 40 degrees west. We're to the west of south. Does that make sense looking at the pictures? And then in this particular, in the last one, we're looking at north, because the acute angle is measured from north, 80 degrees west. It's the west side. Now, looking at these same pictures, if I were going to talk about air navigation, this would still be, the first one would still be north 25 degrees east. In the second picture, with air navigation, and let me change the color. Air navigation would be this complete angle. So in this case, you would have 180 plus 40 degrees, and so we would have 4 and 8 is 220 degrees would be our bearing. If we are talking airplane.
Why do you start where you did?
We always start it from north. Air navigation always starts from north. If we're talking air navigation here, it would just be 25 degrees. It's understood that air navigation starts from north.
And you go clockwise?
And we go clockwise. In this particular, the direction would be 200. If we start here, would be 270 degrees plus 10, and so that would be 280 degrees for air navigation. I think you will have a couple of questions that are air navigation, and so if it just tells you the planes are flying at 300 degrees, that means you're going to measure from north all the way around. Otherwise, if we're talking ships or anything else, it's always an acute angle off of a north-south line. Right? Tells us a sailboat leaves the pier and it heads due west at 8 knots, which is 8 nautical miles per hour. After 15 minutes, the sailboat tacks. I guess that means, if you're a sailor, you know what that means. It's going to turn or change directions. Changing course to north 16 degrees west at 10 knots. We want to find the sailboat's bearing and distance from the pier after 12 minutes on this course. All right, sounds tough. If we will draw a picture, it's helpful. All right, so we're going to draw a picture about what's happening. Let's say that the pier is over here. There's my pier. Is the blue not showing up? Is the red easier?
Can you turn the light up?
It's because I took a picture It's because this is a picture, and that's why it's not looking as good.
It's be really dark.
Can you take notes in the dark over there? Okay. So here's our pier, and it tells us from the pier we're going due west. All right, so I'm going west. And we go 8 nautical miles per hour, but we're going 15 minutes. And then we change course to north 16 degrees west at 10 knots. Now I'm going to, just for a second, here's a north-south line. Okay. And so let me change this back to red. North 16 degrees west is 16 degrees off this north-south line. So it's going to be something like this. So this measurement here is 16 degrees. All right, the question asks us to find the sailboat's bearing and distance from the pier after 12 minutes. So what we are looking for, here's the boat now. And there's its nice little sails maybe. And what we want is this distance. Can you see that color? And we want this bearing. So we're going to figure out what we can do here. Later, you would be able to solve that without right triangles, but right now the only thing we know is right triangles. So let's see what happens if I draw a line down here. I now have 2 right triangles. I have this small right triangle, and then I have a larger right triangle. Okay, if this is P, I'm going to let this be A, and this, we'll just call that C. Now, we've got to figure out what the distance is from P to the end of the red line to where he changed course. Tells us that he was going 8 nautical miles per hour and he went 15 minutes. So how far did he go? What part of an hour is 15 minutes? A quarter of an hour at 8 nautical miles. So this is from here to here is 2 nautical miles. All right? From here to here, where he stopped, he went 12 minutes at 10 knots per hour. What part of an hour is 12 minutes? 1/5. So how far is this distance? 2 nautical miles. All right. I have 2 unknowns here. I don't know what this is, and I don't know what this is. But you can do this, a lot of work. Because I want you to, we've got to be able to take what we've learned and piece it all together. All right. Can we figure out what's this angle?
It's 16 plus 90.
16 plus 90, which is 106. So if this is 106 degrees, what is this angle?
74.
108 minus 180 minus 106, which is 74 degrees. And so what is this angle? This
Which angle?
this one, this acute angle right here. 16 degrees. How did you find 16 degrees? A couple of ways you could do it. 180 degrees in a triangle, so 180 minus 90 minus 74. Anything else?
The rectangle, opposite angle.
Two parallel lines cut by a transversal, opposite interior angles are the same. That's one of those geometry things, and that may not be the exact way that we state that theorem, but that's pretty close. And that's something you'll use a lot. If you have two parallel lines, here and here, the north lines that are cut by a transversal, the opposite interior angles are equal. So if this angle is 16, then this angle is 16. Okay, so can I find the length of side Y?
Yes.
How?
Using
Using trigonometry. Okay, sine of 74 is equal to opposite over hypotenuse, which is what? 2. So twice the sine of 74 is equal to y, and I'm going to leave it like that. I'm not going to get a decimal approximation right now. Okay, let me move this up just a little bit. Now it's going to get brighter again because I've run out of what was the picture. How can I find what x is? Sine of 16 degrees equals what? X over 2. So twice the sine of 16 degrees is equal to x. Okay. So, what did the question ask us to find? Distance. So if we can find the distance, then maybe we can find the angle. And how could we find the distance?
Well, we gotta find x and add x to 2 nautical miles.
Yeah, then just
Okay, add x to the 2 nautical miles and then use what? Pythagorean theorem. All right? So the distance is going to be equal to the square root of this side, which is x. Well, but hang on. We know what x is. X is twice the sine of 16 plus 2 squared plus, what is y? Twice the sine of 74 squared. So the hard part on here is just putting it in your calculator. Okay, we want bearing. And we said bearing is from north or south. In this case, it's going to be from north. And this is the angle that we're looking for. So which angle do I have to find in order to find the other one, which is the small? I can find this angle, can't I?
Oh, okay.
why wouldn't it just be 16?
All right, this is the angle I want, and in order to get this angle, I need to know what this angle is. I have to find this angle so that I can find this angle. This is my bearing. Okay, we have a value for y, and we have a value for this side. what trig function could I use to find, we'll just call this angle P? Tangent. Okay, so I'm going to move this up a little bit. And we know that the tangent, and we call that angle P, is y twice the sine of 74 over twice the sine of 16 plus 2. And Trey, the distance was 3.2. We forgot, I wasn't recording when we came up with the distance. All right, so find the angle P. All right, so we get that angle P is 37. So the bearing then, our bearing then, is it going to be from south or north? North. How do we find out what that is? Is it 90 minus 37 is 53? And is it west or south? West, east, west. So here's our bearing. North, 53 degrees west. Yes?
Could you also do it by finding the full angles of the whole thing and then subtracting 180 to find out?
Harmonic motion represents a point that moves on a line, and it can be represented as d equals a times the sine of omega t, because we're talking about over time, and omega is your angle, and or d equals a times the cosine of pi t. Now, if we're thinking about this ball that's hanging from our paddle board, and we pull it down and release it, do you think that's going to be a sine curve representation or a cosine representation? Cosine. Okay, so if I pull it down, is it going to be a positive or a negative displacement? Negative. So A is your displacement or amplitude. If you were to pull it down or pull something to the left, you would, like if you had a pendulum, I guess a pendulum's going to swing. He said a metronome, so a metronome goes like this. If you start a metronome straight up, what would be your curve? Sine curve. If you pulled it to the left, you would have a cosine, and would we have a negative or a positive displacement? Negative displacement. If you pulled it to the right and released it, you would have a positive displacement. And A, or amplitude and displacement, are the same thing. Right? Our period, just like before, is 2 pi over omega instead of over b. We're using omega instead of b when we're talking about harmonic motion. And frequency, which is the number of cycles per second, is simply the reciprocal of the period. So any time that you ask to find frequency, find the period and take the reciprocal. So we want to find a model for simple harmonic motion that satisfies these conditions. Displacement at time equals 0 is 0. There's no movement from equilibrium, no movement from rest. So which curve is that going to be? Sine curve. Okay, the amplitude is 4 centimeters, so our displacement is 4. And the period is 6 seconds. All right, so how do we find period?
2 pi over omega.
Period is 6 seconds is 2 pi over omega. So omega is 2 pi over 6 or pi over 3. So our function is distance equals amplitude, A, 4. We said it was a sine curve, and it's pi over 3 times t, because we're talking distance over time, not y and x. So that's pretty easy. I mean, you've already had practice doing these kinds of things before. You like that better? No?
No.
You don't like that better than bearing? Okay, let's look at the second part of this. Okay, here's our equation for simple harmonic motion. D equals 6 cosine. We don't know what the action is, but this is our equation. D equals 6 times the cosine of 3 pi over 4t. We want maximum displacement. We want frequency. We want the value of d when t is 4. And then d is the least positive value of t for which d equals 0. So let's take these one step at a time. What is our maximum displacement? Maximum displacement is 6. All right. In order to find the frequency, what could we do first? Find the period. Okay, so what is our period here going to be? 2 pi over 3 pi over 4, which is 2 pi times 4 over 3 pi. So that's 8/3. So what's the frequency? Okay, the frequency is 8/3 cycle per whatever our unit of time is. Wait.
Wouldn't it be 3/8?
Yeah, yes, it would. Sorry. 3/8.
Why is it 3/8?
Frequency is the reciprocal of the period per unit time. We don't know what our time period is here, so it's cycles per unit time. Okay, so we've got A and B taken care of. C says to find the value of D when T is 4. So how do you think we're going to do that? Plug it in. So distance equals 6 times the cosine of 3 pi over 4 times 4. What is the cosine of 3 pi? -1. So distance is -6 when time is 4. Now the last one says the least positive value of t for which d equals 0. So how would we go about solving that one? No, not putting it in our calculator. Okay, I'm going to go ahead and rewrite my equation here. 6 times the cosine of 3 pi 4t. What did you say, Colin? Set this equation equal to 0. So 0 equals 6 times the cosine of 3 pi over 4t. I'm going to divide by 6. And 0 equals the cosine of 3 pi over 4t. Because we want to know when is the distance equal to 0. So we want the least positive value. So I want to know when is the cosine of 3 pi over 4t equal to 0. So let's think about this. What does the angle have to be in order to get a cosine of 0? It has to be, it could be pi over 2, it could be what? Okay, but we're not going to go backwards here, we're just going to go forwards. 3 pi over 2. Okay, so the least positive distance, I think it asks for least positive, is going to be pi over 2, so now we can solve for t. If we're going to use pi over 2, 3 pi over 4t equals pi over 2. So we can multiply by 4 over 3 pi. The pi's cancel, and we get time is 2/3 units, whatever the time is. Okay, so time is 2/3. Questions there? Okay. Yes, you have a question? Okay. Okay, there is the assignment.